So 1.7 is about story problems, and I thought I would just give you a couple of examples of story problems. So here's a mixing problem. Let's suppose that I run a coffee shop, and I've got two coffees in my storeroom, and I won't bother making up names. I'll just call them Coffee A and Coffee B. Let's say Coffee A costs $12 a pound. But Coffee B is the cheap stuff. It costs only $3 a pound. So a typical question in this section would be, how can I mix these, some of Coffee A and some of Coffee B, to obtain 5 pounds that costs $8 a pound? Okay, your solution to a story problem should always begin with an explanation of any variables that you're going to use in the problem. So that explanation usually starts with the word let. Let x, say, equal, what do I need a variable for? Well, I need to know how much of Coffee A and how much of Coffee B to use. So I'm going to let x equal the amount of Coffee A in my mix. And while I'm at it, it's good to specify the units, measured in pounds, obviously. I don't want to measure it in kilos, right? I mean, everything is in pounds up here. But let's measure the units. I'm measuring it in pounds. And let's let y be the amount of Coffee B in my solution, also measured in pounds. The trick is to come up with, well, now I've got two variables, to come up with two equations so that I can solve for these two variables. One of them is easy. It's the total number of pounds in the mix. I know the total number of pounds is 5, so x plus y has to be 5. In fact, some of you might be saying, why even bother with another variable? Why don't you know y is going to equal 5 minus x. Well, that's true. You could say y has to equal 5 minus x, and you could have the entire equation written in one variable. But just in case that doesn't occur to you, I'm going to write it in two. So one equation comes from the total number of pounds in the mix. The other comes from, you'd think it'd be the cost, but it's more like the total dollars. The total cost of this mix. I mean, after I put this coffee together, I don't have something that costs $8. It costs $8 a pound, but there's 5 pounds of this junk. So the total cost is going to be $40. 5 pounds times $8 a pound. How much of that was due to the cost of x, and how much was that due to the cost of the y? Well, if I've got x pounds of Coffee A, and Coffee A costs $12 a pound, then the amount of Coffee A in my mix is costing me 12 times x. That's $12, right? Dollars per pound rather, times x pounds. You can even see the units cancel their dollars per pound. That's the 12, and the x is measured in pounds. And sure, the units cancel and you're left with dollars. So the amount of Coffee A that I use in my mix is costing me 12x. The amount of Coffee B that I'm using costs me 3y. So here's the one equation, there's the other that I need to solve for x and y. Isn't this just like a problem in section 1.8? Yeah, so what I'll do is solve it just like in 1.8. I'll solve for one variable in terms of the other. I think it'd be equally easy to solve for x or y in this problem, but let's solve for, say, y by subtracting x from both sides. Now I take that and put it in there. So the second equation becomes 12x plus 3 times 5 minus x equals 40. In fact, that's the equation you would have gotten if you were one of those people that said, I should let x stand for the amount of Coffee A, and then I know that the amount of Coffee B has to be 5 minus x. Anyway, let's solve this and learn what x is. I'll distribute the 3 through there. And collect up like terms. I'll subtract 15 from both sides. Divide by 9. I'm perfectly happy if you leave the answer in this as an improper fraction where the numerator is bigger than the denominator. That reminds me, I see this mistake on exams sometimes. 25/9 does not equal to 5/3. You can simplify fractions by canceling common factors. 25 and 9 have no common factors. The thing that sometimes fools people in this problem is that 25 and 9 are both perfect squares, and so they say, well, it must be that I can simplify the fraction by just undoing the squaring, I guess sort of canceling the squaring from top and bottom. Not legitimate. 25 ninths is not 5/3. I mean, 25 ninths is almost 3, it's almost 27 ninths, whereas this is not even 2, it's 1.67. So what have I got there? Is that the solution? Well, I still need x, or rather I still need y. I mean, there were two variables involved, so I really can't answer the question without the 2, I don't think. Y is going to be 5 minus x, so that's 5 minus 25 ninths. 5 is 45 ninths, so 5 minus x is 20 ninths. It's always good form to give, to express the answer to a word problem in words. So I'll just say use 25 ninths pounds of coffee A and 20 ninths pounds of coffee B, and we're done. So here's another problem that we see in the homework. I just sort of call them motion problems. It's where there's two motions, two velocities that add or subtract to determine your speed. So imagine that you're someplace where there's a moving sidewalk, the town of the future. There's sidewalks that move, and you can get on the sidewalk and be shuttled down the road or down the sidewalk. But if you really want to go fast, you'd walk with the sidewalk. And if you want to annoy people, you'd walk in the opposite direction of the sidewalk, so you're kind of going slower if you just want to be a pill about it. Let's suppose I've got a moving sidewalk. It's 60 meters long. And I discovered that when I'm walking with the sidewalk, it takes me 60 seconds to go from one end, from the beginning to the end of the sidewalk. But if, just to be annoying, I'm facing the opposite direction, I walk in the opposite direction while the sidewalk is moving me along, it still takes me from the beginning to the end, but it takes me 90 seconds to do it. So what if after doing this they kick me off the sidewalk and they make me walk the 60 meters, on my own without the sidewalk? How long would it take me to walk that 60 meters by myself? So let's see. I'm going to let x stand for my walking speed on solid ground. And speed is measured in meters per second. And think about how fast am I actually going when I'm on the sidewalk. That depends on how fast the sidewalk is moving. It didn't actually tell me how fast the sidewalk was moving. It told me how fast, it didn't tell me how fast I would move along the sidewalk if I just stood still. It says if I'm walking with it or against it. So I think I have to have another variable. Let's let y be the speed of the sidewalk. Just to be clear, it's also in meters per second. So how fast am I walking when I'm on the sidewalk walking in the same direction? Well, that's x plus y. That's my actual speed when I'm walking in the same direction that the sidewalk is carrying me. So walking with the sidewalk helping me. How fast am I going when I'm walking in the opposite direction of the sidewalk? So I'm moving from the beginning to the end of the sidewalk. The sidewalk, every second, the sidewalk takes me y meters forward, but I'm walking in the opposite direction, so I go backwards x meters every second. So that's negative x plus y. That's going to be my actual speed when I'm standing on the sidewalk walking in the wrong direction. Right? Every second that goes by, the sidewalk moves me y meters forward, but then I walk x meters backwards in the same second. So my actual distance traveled is y minus x. Well, let's see, they told me that when the sidewalk is 60 meters long, when I'm walking with the sidewalk, it takes me 60 seconds. I think they told me x plus y. My speed walking with the sidewalk must be 60 meters divided by 60 seconds. That's 1 meter per second. That is, x plus y has to be 1. Here's a good time when it's good to have the units, to think about the units. I said x and y would be in meters per second, so I'm kind of relieved to see that if I add x plus y, I've got meters per second again like I'd expect. Let's say they also told me that when I'm walking in the opposite direction, it takes me 90 seconds. So negative x plus y, my speed when walking against the sidewalk, against the grain, is 60 meters in 90 seconds. That's 2/3 meters per second. So negative x plus y must be 2/3. Here are my two equations in the two unknowns x and y. I'll solve them just like I did back in section 8.1. I'll solve for y in this first equation, say. Y has to be 1 minus x. And then I'll put that into the second equation. So the second equation becomes negative x plus 1 minus x is 2/3. I'm going to get rid of these parentheses because I'm just adding. The parentheses don't do anything. So the left side is 1 minus 2x. Is 2/3. I'm going to add 2x to both sides because something about negatives I don't like, so I'm just going to get rid of them right now. I know I have to move x somewhere anyway, so I'll just add, I'll add 2x to both sides. I'm going to subtract 2/3 from both sides. So 1 minus 2/3 is 1/3. 1/3 equals 2x. So x must be 1/3 divided by 2. Quick, what's 1/3 divided by 2? It's 1/3 times 1/2. It's 1/6. That's meters per second. What's y? Generally, when I have two equations and two unknowns, I expect that I need y. The truth is, I could find it, because y is 1 minus x. 1 minus 1/6 is 5/6. And that sidewalk was traveling 5 times as fast as I was walking. But if you look carefully at the problem, it said, how long would it take me to travel 60 meters on my own? It's asking for, essentially it's asking for x. It really doesn't ask me how fast the sidewalk is traveling. So this is one of these problems. If I read carefully what the problem asks, I don't actually need both of the variables that I invented to answer the question. Does that answer the question? Is the answer 1/6? No, the units are telling me that's not quite right. What units do you expect on this question? How long? The answer's got to be something in seconds, not meters per second. So it must be something to do with the fact that the sidewalk is 60 meters long. So the answer is not the x, 1/6 meters per second. The answer I'm expecting is something in seconds. Some number of seconds. So how do I combine 60 meters and 1/6 meters per second? Here's where it pays to think of the units. You either multiply or divide these. If I multiply them, I'll get meters squared per second. That can't be right. How would I get just seconds? Well, if I took meters and divided by, let me just double check this. Took meters and divided by meters per second. I think I'll get seconds. Let's just double check. So invert and multiply. I think of units like this, m and seconds, as variables. So I treat them just like an x and a y in some problem. So 60 meters times 6/1 times seconds per meter, mech, seconds per meter. And yeah, the meters cancel, and I'll be left with seconds. It must be 360 seconds. That is, it'll take me 360 seconds, that is 6 minutes, to walk 60 meters on solid ground. and we're done.